Welcome to Tuesday Talks. In today's episode, we'll be diving into the exciting world of artificial intelligence, language models, and machine learning. Please note that the views, opinions, and comments expressed by our guest speaker and contributor are their own and do not necessarily reflect the official stance of Link Digital. Our goal is to present a diverse range of perspectives to spark thoughtful discussion. Viewer discretion is advised.
Everyone. Welcome to Tuesday Talks. Here we are exploring future of data management. I'm Alex Gostev, second contributor, and today we're joined by Yevhen Krasnokutsky, who is PhD, ML, and MLOps lead, to discuss how artificial intelligence is transforming the way we manage and utilize open data. Hey, Yevhen.
Hi, Alex. Happy to be invited. Thank you for the invitation.
Cool. We know Yevhen for quite a while, and Yevhen is my go-to person if I have machine learning, AI, large language model question, or I should clarify some technicalities I have a hard time understanding. So Yevhen is quite deep into his knowledge, and he's very much practical. This is a brief introduction for you, Yevhen. So, what are the most promising applications of AI that you worked with?
There are a few branches of AI applications, I would say. On my personal opinion, there are two main, well-established and promising. So, as a practical machine learning engineer, I mostly work with well-established approaches. Still, I prefer to look for promising applications, and there are plenty of them. So basically nowadays we see that LLMs are at their peak, but there are many more interesting technologies that are more promising, I would say, on my personal opinion, especially those technologies who deal directly or indirectly or interact with our physical world. For example, it's machine learning techniques for creating new materials, robotics, things for brain-computer interface and prosthetic limbs. It's kind of interesting and promising and beneficial areas of application of machine learning.
Okay. If I'm getting you right, you are saying that LLMs are overrated, they're a bit hyped, and we have much more in the world of machine learning and all that stuff to work with, and applications. They're much wider than ChatGPT or Claude or whatever is occupying our news feeds right now.
Definitely LLMs are very good technologies. They can solve many problems, especially when we deal with the text. Basically, LLMs are for text. They can navigate through text. They're useful for searching some patterns in text, for question answering, summarization, even like a personal support bots. It's really interesting application.
Mm-hmm.
We can use LLMs in technologies I mentioned before, like robotics. A lot of attempts being done to incorporate LLMs into reasoning of robots to navigate our world. So LLMs, they are slightly high, but there are many more of their application we could use in the future than we have now.
Okay. Talking about technologies that exist, so I imagine you were having aggregated news feed, or you're a professional area. And so some things capture your attention and you're like, oh, that's interesting. Oh, I like it. What's that? So you mentioned robotics, creating new materials. maybe latest thing that captured your attention and you thought, okay, yeah, that's really interesting. I would be happy to work with it.
So you're basically asking why I'm choosing a specific direction. What's mindset behind the choosing some direction? So
yeah.
I have like engineering background and scientific background. So everything that deals, as I mentioned before, with the physical world is super interesting. With the things that deals with our brain directly or indirectly with brain-computer interface, it's super exciting. It's like, releasing the gene out of the lamp. So right now, this machine learning is something inside of the lamp, and we have to release it to show the complete potential of artificial intelligence. So imagine different kind of technologies that really could help us in navigating the world, dealing the world, doing real hard job in mining, for example, in surgery. And imagine a real assistant in a surgery room. It's mind-blowing, in my opinion. It's super cool.
Yeah, that's fair. And that's quite interesting. Mostly, if we're talking about AI, we're talking about tech companies. And tech companies are top of stock price capitalization rankings. But there are much more. There's agriculture, there's healthcare, and a lot of areas where we have operational machines, but these machines aren't AI smart. So making them smarter, making them, I don't know, be able to reason. I don't know if it makes sense, or if it's a buzzword that we're using all the time to describe how smart machines can be. That should be quite interesting. That's cool. So this is how you see the future of this area. It will become more physical.
Yeah, in my opinion, it will definitely become more physical. So we have the idea of self-driving cars, but is the application of LLMs and computer vision limited with just the self-driving cars? Definitely not. So we can see different drones or can navigate through the difficult areas or buildings, helping like in a battlefield, for example, here in Ukraine, or helping people to assess, for example, in agricultural areas, if crops are in a good state, if there are enough of water supply, for example, if there are any diseases on the crop field, something like that.
Right. Okay. Thanks, Yevhen. Getting closer to data management and the question on data quality. Do you know about applications of AI in improving data quality, or maybe most promising of them?
Yeah, can use and use AI for data improving. So in my machine learning projects, I use different machine learning techniques to at least clean up the data. For example, you have a bunch of images and there might be some duplicates, and we could use different approaches, for example, with foundational models, just to get rid of duplicates. The same things we can tell about text. For example, you have a huge corporate text, and you want to aggregate the text, make this text as a data set of some sort of structure. So you have unstructured text, and you want to make it like structured in the form of JSON or CSV or something like that. We could try to use LLMs to automate this tedious task for extracting different facts and composing different tables based on the initial text. So another interesting thing I just thought about is if you have, for example, different sources of the textual information, different websites, databases, and so on and so forth, we want to aggregate this data in a single data warehouse or data lake, and it's quite tedious job for big data engineers. We could try to use LLMs to make this job easier, to transform different kinds of structure into a standardized one, to clean up the data while we transform it, to, for example, remove duplicates, as I mentioned before. And for example, if we have like a text in a different languages, we could try to use LLMs to translate the text. They're quite good in this kind of task.
Okay, so it's a data transformation, and it's processing of data, so it's better suited for use. So it's like preparing data for LLM. Is it close to what you said?
Yeah, we can use LLMs for preparation, especially when we are forming like our prompts. So it's part of data preparation, I would say.
Okay.
Prompting the data and the output of the model is some nicely structured output.
Okay, got it. What role does AI play in making open data more discoverable and more usable?
Open data, it's quite an important thing in machine learning world, and it's from time to time it's really kind of difficult to navigate through the data. A lot of tables, a lot of different structures, a lot of meanings and semantics between different tables and data sources and so on and so forth. If you're talking about raw data, textual data, tables, we could try to use LLMs to enrich our data with some specific and meaningful metadata. For example, this table is about pets, and this table is about crops. It's easier to navigate such a data via, for example, user interface, or, for example, with the use of such a techniques like chat with your data. You probably heard about this direction of or approach for using LLMs. Just chat with your documents. The same thing we could apply for data. Chat with your data. We have a bunch of data. Let's chat with it. What kind of structures, what kind of statistic it has, what kind of meaning we could extract, and so on and so forth.
Okay, that's quite interesting, because being able to chat with the data you have changes how we consume this data, because usual workflow for an open data portal is you're using search, you're looking for something, you're using search, you're finding data sets, you're downloading data set, and then you're using data set. Meanwhile, if you can chat with data, you're bypassing all these paths, and you can ask questions you have in mind, first of all, and then you're getting answer from the system. Would you trust these systems? Because usually LLMs has problems with bias, with hallucinations. Do you think that it's a reliable way to use LLMs?
Yeah, the biases of LLMs and hallucinations is kind of problem nowadays. So would I trust the results? I would trust the results on 95%, I would say. So it's sort of, to the point of its hallucination. Definitely, we have to keep in mind that models can hallucinate, or, let's be more direct, lie to us with its output, or mislead us with its output. But still, in general, it has LLM's output might be a solid foundation for understanding the data.
Mm-hmm.
Definitely, the output might be polluted with some sort of hallucination, but the amount of hallucination is quite small to get a general idea. If you're asking for, is there any specific data here in this huge pile of data, and the model gives you examples and says, yes, it has. So you have a general idea about the data. Oh, I see. So I can use the data in a more classical manner with downloading and manual data processing and so on and so forth.
Okay. So it can be you can combine the approach that you have, the workflow you have, with discovery of what you can get out of it, or with thinking through what you can get out of this data. But these approaches are complementary. It's not that you were canceling the previous workflow and now you have the new one. It's more like a conversation with the data, right?
Yeah, it's more like a conversation, and definitely I won't change like a classical approach in my project with pure LLM approach, despite the fact they're really promising and interesting instruments. I would prefer to combine them.
Interesting. Are you practically doing this, or did this year, previous year?
My project currently is mostly computer vision projects, so I have some experience with LLMs and their outputs. They're really quite promising, especially with a combination of retrieval augmented generations. So we could really chat with the data, really chat with a huge amount of documents and so on and so forth. But this RAG technology requires a lot of fine tuning. You can't just put your data in RAGs and it works. Unfortunately, it doesn't like that.
Okay.
Most of the times, at least.
Okay. I heard from you before that RAGs aren't that sort of, it's not a plug and play. You should tune this RAG, you should make it work, and it doesn't work all the time as was expected. Can you please give a bit of an insight on this path? Because RAGs are quite popular for a reason. And first question is, what is the popularity for RAGs? For what reason? And the second is, what are pitfalls that you know that RAGs have? And maybe they're not very well, shown up in public discourse.
Let's start from the end. RAGs are really popular and one of the most efficient tools to incorporate LLMs. Why would we even need retrieval augmented generation? Imagine you have a huge text. If the text can't fit into a model context, LLM context, we can extract meaningful data from the whole text. We can extract meaningful data from the chunks that fit a model's context. Some models have 8K context length tokens. Some models have 2 million tokens. It's quite impressive and huge amount of tokens. But not many companies can host this kind of models, especially Google's models. They're called the source. You have only API. And if you want your in-home LLM, for example, you can't trust for third-party APIs. You would like to host your own LLM. And open source LLMs usually don't have big enough context window. To overcome this limitation, clever engineers came up with RAG technology. So it's basically chunking your huge text into chunks that basically can be fit in the model's context window, and make these chunks consumable and searchable for LLMs. And one of the main problem here, how to chunk your data properly. You can do it automatically. It doesn't work in general cases. Sometimes it works, sometimes it doesn't. So one of the, on my personal practical opinion, the most difficult thing is in RAG application is proper chunking. So meaningful information should be placed in a single chunk, not split between different chunks. That's basically it.
Okay, that's interesting. So say I'm a user of Anthropic Claude, and they have these projects, and within project I can upload up to 20 files for 30 megabytes each. And so it's a foundational model, Sonnet 3.5 right now. And then it's this project knowledge base. Is this the RAG, these documents that I'm uploading?
I'm not really into the cloud system, I guess. So my not really professional here, I would say, opinions, but probably, yeah, they have some sort of RAG and some sort of clever technique to automatically chunk and store your data.
To reuse it then.
Reuse it then, or probably they have some, I guess, maybe internally quite huge models with huge context. But I think if they had, they would publish then this model.
Okay. Okay. Thank you. On this account, so when you say context window, it's a window for prompt. May you please kind of give more details on what it is? Because I sense that this is the central term in your explanation of it.
Yeah. I'm trying to come up with proper explanation. So imagine what's a context window. Imagine your model can consume just 10,000 tokens at a time. 10,000 tokens. And as a user, you have to feed into this 2,000. I said 10,000 or 2,000, sorry. 10,000 tokens. And as a user, you have to feed all of your data in this 10,000 tokens. So it's a prompt, it's an example, and it's model output. All of this should fit in a 10,000 tokens.
And the model output. Okay.
So the model can then see its output and generate the next text, next word, next sentence based on its previous generation.
I saw this is in the explanation of how transformers work. They generate the output and then they come back, and then they fix this output and then they come back. Okay, cool. And when you say token is a letter, is a word, is a logical unit. What's that?
Oh, it's a quite complicated. So basically, it's a few letters in a row. Sometimes it's just one letter. Sometimes it's 3 letters. Sometimes it's just a space bar or enter symbol or new line, new character symbol. That's it. Different models have a different set of tokens. So tokenization is a separate topic.
Okay, it's a separate huge topic. Okay. If I'm a company owner and I would like to implement my in-house large language model, and I would like to use RAG, because everybody else uses RAG, then why should I use RAG? How would you explain it to the company owner? Why RAGs are so important to use?
Okay, not all companies should use RAG. Why would you even think about RAGs? The main application of RAGs is a search of information and chat with information. Make your information easy accessible. For example, your company has huge amount of data, documents in different sources, Google documents, Microsoft documents, somewhere in Jira, somewhere in the chats in the Slack, and so on and so forth. And you want to have a unified view on all of this data. Sometimes different companies and managers in different companies put different information, different locations. Again, as I said, Google Doc, Jira, and so on and so forth. And RAG is a technique that could help you to unify all of these sources and make them searchable. For example, you want to know how to get a vacation in your company, but you can't find directly in a huge pile of documents your company have, because there are a lot of iteration of processes of the development of the document, a lot of versions and so on and so forth. Based on RAGs, you could just ask in a simple chat form, how can I ask for a vacation, for example, in my company? And with a properly tuned RAG, you can have like a super short answer. Step 1, step 2, step 3, and a link to the document. That's it.
Okay, that's interesting. But you're saying not all the companies should use RAG, so it's possible to have LLM without RAG, and it still would do the job. Well, then, if I'm the company owner and I want LLM, and for some reason I discourage to use RAG, why it could happen? Why not everyone should have a RAG in their own?
RAGs is for textual data. Assume your company has a lot of textual data, but not all companies have a lot of textual data. For example, there are a lot of companies dealing with cameras, computer vision, some event tracking on the road, and so on and so forth. Mostly no text here. So why should we implement LLMs or incorporate LLMs? Without no reason to do that. We should start with a business understanding and business needs, and what kind of tasks business want to solve. Either data discoverability, data availability, and you have a lot of text. Let's try to use LLMs and RAGs.
Okay, got it. Yevhen, thanks a lot. It's supposed to be the first conversation, to be short, not to overwhelm our viewers too much. And I know you have a lot to say. And thank you very much, because I'm learning all the time we have a conversation. It was pure joy to have you today on this talk.
Thank you for your questions, Eric. Interesting and sometimes hard to answer, like on top of my head to have an answer. Thank you.
Great. Thank you for joining us on Tuesday Talks.